Welcome to Extra Class Online Academy, your #1 hub for free quality education, anytime, anywhere. We offer a wide range of online lessons covering ZIMSEC subjects from Form 1 to Form 6, Cambridge IGCSE, South African Matric from grade 10 to 12, and many other valuable courses to help you succeed academically and beyond. Whether you're preparing for exams, catching up on classwork, or learning something new, we've got you covered, and the best part? It's all absolutely free, no matter where you are, in Zimbabwe, South Africa, or across the world, education should be accessible to everyone. At Extra Class, we believe in learning without limits. So go ahead, subscribe, explore our lessons, and join thousands of learners already upgrading their knowledge the smart way. Let's grow together. Extra Class Online Academy, learn free. Learn smart. Learn anytime.
Right, after taking the readings from the wet bulb and the dry bulb thermometers, you have to interpret what the reading means. Right, so let us look at the interpretation. If there is a huge difference between the thermometer readings, then it means the air is dry and humidity is low. So dry air has got low humidity. Dry air has got very low water vapor. When there is less difference, it means the air is moist, right? There is some moisture in the air and humidity is high. When there is no difference at all, so this happens when it is raining, then the air is saturated. When it is saturated, we are saying there is no more room for more moisture. It is very humid. So this is how we interpret the readings of the wet and dry bulb. Right, so we have looked at how it is recorded. Here is also a digital hygrometer and the thermometer. So a digital hygrometer and thermometer is simply a sophisticated machine that measures and the humidity. So humidity can be measured using the wet and dry bulb. You can see here. Here is our digital hygrometer and a thermometer. Now we are going to look at some words or how we describe humidity. So humidity can be measured in several ways, but relative humidity is the most common. In order to understand relative humidity, it is helpful to first understand absolute humidity. So we are going to look at these terms so that when you see them in your examinations or your test, you are going to know how to define them. So what is absolute humidity? This is the mass of water vapor divided by the mass of dry air in a volume of air at a given temperature. So, right, it's a little bit of a math, but it is quite easy to understand. If air is hot, then the more water it can contain. If air is hot, it can contain more water vapor. So absolute humidity is expressed as grams of moisture per cubic meter of air. What it means is hot air, right? We have what our hot air. It means more vapor. Okay, that is our absolute humidity. Now let us look at relative humidity. Now, relative humidity is the ratio of the current absolute humidity to the highest possible absolute humidity. So, right, Here we have the current. Okay, what is currently in the air? Okay, what we currently have versus the maximum possible. You see, this gives us a relative to say currently we have let's say we have 10 grams of water vapor per cubic meter versus the maximum possible of 100 grams per cubic it's m3 per cubic meter, right? So this is how we talk of relative humidity, right? So if we express it like this, 10 over 100 times 100, it will give us 10%. So we can say relative humidity is 10%. Okay, so we have to measure the current humidity, then express it as a percentage of the maximum possible, which is obviously 100%. So this relative humidity depends on the current air temperature, which means if it's hot, then relative is high. If it's cold, then relative is low. A reading of 100% humidity means that the air is totally saturated with water vapor and cannot hold any more water vapor, creating the possibility of rain. However, this does not mean that the relative humidity must be 100 in order for it to rain. No. So, but it must be 100% where the clouds are forming, which is right up the sky. Relative humidity near the ground could be much less, even if the clouds are forming up in the sky. So do you have any question about relative humidity, about hygrometer, and all those? You are welcome to post them in the comments, and one of our teachers who is going to explain them to you. So here we are looking at a chart of the difference between a wet and dry bulb temperatures. So this is the temperature readings, and here we are given the recordings. Relative humidity at a given temperature as shown is on this chart. So that is all we have on humidity. Thank you very much for your time, and please watch the next video where we are also talking about the rain gauge. To measure the amount of rainfall received over a given time, a rain gauge is used. So the instrument comprises of a collecting can, a funnel, and a measuring cylinder. It is a very simple machine, as you can see, a very simple instrument in case. Yes, it's a very simple instrument. The instrument is placed at the weather station. Then a standard rain gauge is about 13 centimeters in diameter. It must be fixed onto the ground with its top being 30 centimeters above the ground. This is to avoid overland flow water flowing into the collecting can. The funnel will collect and direct the rain received into the collecting can. The overflow can help to prevent surface runoff from flowing into our collecting can. So accurate measurements are received by collecting water falling in straight into the rain gauge from the atmosphere, and then after the water is collected, it is poured into a measuring cylinder so that we can take readings. Let us take a look at this. So here is our rain gauge. It must be at least 10 centimeters from ground. there is an overflow can, and then here is a 30 centimeter open at the top and a funnel. So raindrops will come through this funnel and then they are directed into the collecting can. This one at the bottom here is our collecting can. After the rain, you take the collecting can, you pour the water into a measuring cylinder, and then you measure how many millimeters of rain you have received. Right, new developments have replaced the old standard rain gauges with this one. So this rain gauge is placed on a wooden post about 90 centimeters to 1.5 meters above the ground. This new rain gauge, the gauge is both the collecting can and the measuring cylinder. So here you can see this part, which is the collecting can, and this part, which is graduated, which means it has got some readings. This is for measuring. This new rain gauge means we have reduced our work. It does everything. What you simply do is to empty and throw away the water after recording. The gauge is both the collecting can and the measuring cylinder. Once the water has been collected, the rain readings are taken by reading the figure just below the level of the collected water. The readings are recorded on a chart or in a record book. Thank you very much for watching. Now we go to the wind vane. When the wind blows from a certain direction, it hits the back of the arrow. This back of the arrow, which is called the tail, and then it will rotate on its pivot. Here's the pivot. The arrow rotates until it points to the direction where the wind is blowing from. So this arrow is going to show us where the wind is coming from. So the wind will be blowing like this direction. The arrow will show us that the wind is coming from the west, from the north, from the east. So to take the measurements, record the direction where the arrow is pointing. As simple as that. That is how we record wind direction using a wind vane. Now, when we have recorded, we come to a wind rose. The wind rose is therefore a device used to record wind direction. So here we are looking at our wind rose. This one and also this one. So how does it work? When the wind blows from a certain direction, it is marked on the corresponding direction on the wind rose. So it means we are going to start off with our wind rose just like this, which is plain like this, northeast. We have our east, south, east. This is east, not. Okay, I've made a mistake here. This is our east. This is south. This is southwest. This is west. This is northwest. Okay, so we start off our wind rose like this. Okay, as you can see, there is nothing. Right, now so let's say day 1, the wind blows from the north. We come and put a mark. Day 2, so mark 3 like this. This is how we record. See, we are recording the direction of the wind. We are recording the direction of the wind. All these are the days in a month. Until we are done with the month. And then we will come up to a thing like this, or a draw something like this. Right, the wind rose on the left shows the direction of the wind by plotting the number of days the wind blows from a given direction. On the same rows, the number of calm days is recorded at the center. For example, it can be 5. Now, to find the calm days, Add all the days plotted on the wind rows, then subtract the answer from the total number of days in a month. The wind rows on the right shows bars on the direction from which the wind is blowing. The wind direction from which the wind blows most is called the prevailing wind. So coming to our simple wind rows, we can see that wind from the north is the prevailing wind, and we never received wind from northwest or from southeast. We never received wind from these three directions. So we have to add how many numbers are these, each one representing a day. We subtract them from the number of days in a month, then we can find our calm days. So in this case, we have 23 days of wind. So if we have 23 days of wind, it means how many days are calm? Now we say 30 minus 23, which gives us 7 days. These 7 days are called calm days. Okay? A calm day is when there is no wind. There is no wind. These are calm days when there is no wind. Now you know. So the direction from which the wind is blowing mostly from is called the prevailing wind. So in our case, our prevailing wind is from the north. Thank you very much for watching. Let's continue to cup anemometer. A cup anemometer is an instrument which has got 4 cups attached at the end of the horizontal arms. So we have got this horizontal arms. Here is a cup, here is a cup, here is a cup, here is a cup. These cups of the instrument catch the wind and are forced to turn. So as the wind is blowing from this direction, it will come and fill this cup. So when this cup is filled, it is forced to turn and rotate. This one also comes, is filled, and is forced to rotate. Now it will continue rotating until it starts to spin very fast. When it starts spinning, it means we now have a measure, or we can now measure the speed of the wind. So as they turn, the dial attached to the cups also turn the meter on the instrument, which shows the speed at which the wind is turning the cups. So you are going to read this speed here on this cup anemometer. This will give us the wind speed. That is how we measure wind speed.